Hi everyone, welcome to Numbers Online School. Today we'll be going through another problem from the East African Mathematical Olympiad 2025. Here's a view of this problem. Let A1, B1, C1 be 3 points on the sides BC, CA, and AB respectively of the triangle ABC. Prove that there are three cycles circumscribed by the triangles A, B1, C1, B, C1, A1, and C, A1, B1 intersect at one point. So what we have is a triangle ABC, and then we are supposed to prove that for any given points A1, B1, and C1 along the edges of the triangle, when we draw the first cycle through A1, B1, and C1, and another cycle through C1, B, and A1, then these other 4 points will also, in the cycle through C, B1, and A1, then they will meet at a single point, which at this point it will be inside the triangle ABC. So in this case, I have already drawn the first two cycles, and now I have to show that at this, whenever they intersect these first two cycles, then the third one through this point, and this point will also pass through this common point of the first two drawn cycles. So it has to be something like this. So we must have that these 4 points, the rest of the points, the third cycle also passes through this common intersection point. So in order to prove that, as I have shown below, we have to draw the first two cycles, and then I'll try to define some segments from this point to the end, and from this point to that end, and from this point again to that point. So we have three quadrilaterals here. We have this quadrilateral, we have this quadrilateral, and then we have this quadrilateral. We have three disjoint quadrilaterals, and we already know that the upper quadrilateral is cyclic by definition, and the this quadrilateral B, A1, C1, let's call this point point T. Then this quadrilateral is also cyclic by definition, and now we have to show that this quadrilateral formed by B1, C, A1, and T is also a cyclic quadrilateral. Now, in order to do that, we will use some cycle theorems that the fact that the sum of opposite angles, whenever you have a cyclic quadrilateral, then the sum of opposite angles will always add up to 180 degrees. So in this case, because we already know that the upper quadrilateral is a cyclic quadrilateral, so that means that this angle right there plus this angle A, they will add up to 180 degrees. Likewise, when we add this angle of the lower left quadrilateral and the angle B, they will add up to 180 degrees. So in this case, because we know that the converse of this theorem is also true, whenever you have a quadrilateral which satisfies this condition, that the sum of opposite angles add up to 180 degrees, then it has to be a cyclic quadrilateral. So in this case, what we have to do is to show that the sum of this angle plus this angle is also equal to 180 degrees, implying that this quadrilateral is cyclic as the problem describes it. So in this case, we have to do some angle computations. We know that the sum of these three angles is a full turn at 360 degrees. So in order to describe this angle here, angle A1 T B1, this is point T, A1 T B1, so angle A1 T B1, that angle is 360 degrees minus the sum of the other two angles. So it will be 360 degrees minus B1 TC1 minus angle A1 TC1. Again, by definition, as we have already saw, these angles are supplementary compared to the angles at their respective vertices. So this angle and this angle, they are supplementary. And so we can substitute in place of the angle B1 TC1, it's actually 180 degrees minus, I just put angle A to signify the angle at the vertex A for the triangle ABC. And for this angle, I'll do the same, which is 180 minus its opposite angle, which is angle B. Like that. And so what we end up getting is 360 minus 180 minus 180. So they cancel out. What we are left with is the sum of angle A and angle B, angle A and angle B. But we already know that famous theorem that the sum of the interior angles of a triangle, they add up to 180 degrees. So this sum of these angles, when added to C, is 180 degrees. So the sum of A and B has to be equal to 180 degrees minus the angle at the vertex C. And so we have shown that this angle right here, angle A1 TB1, is supplementary to the angle C. So in this case, the sum of these two opposite angles, they necessarily add up to a straight line, angle of the straight line 180 degrees. So we must conclude that these 4 points, they have to be consecutive points. In other words, they all lie on a singular cycle. And with that, we are done with this problem. Thank you for watching.